at Medicines from the Earth in Black Mountain, North Carolina in 2017. For more information on our conferences, lecture notes, and recordings, visit our website, botanicalmedicine.org.
So the conference this week is about inflammation. And I just want to kind of preface this talk with a little bit of the concepts I want to just make sure I hit on. And one is just the fact that this world is a nonlinear world, and these bodies are nonlinear bodies. There's nothing about these bodies that looks like the maps that we make. We are not the biochemical pathways that we write about and describe and make maps of. If you've ever hiked in the wilderness, you'll know that the map is not the terrain. You see where you're going on the map, but you get there and you never know what's going to be in the wilds. And that's how it is in nature. And so when we talk about inflammation, I want to make sure we understand that there's this nonlinear process that's happening and that everything is a flux. It's all happening in balance with each other. It's feedback loops and cascades and signaling networks. It's not so simple as we make it seem. And so when we talk about plants, we're talking about nature, and we're talking about nature that works in its own nonlinear fashion. It works with our bodies, and we work on the plants, and the plants work on us. And I really want to keep that in the forefront of our minds, even as we dig into the biochemistry, as we look at the biological pathways, the physiology. All that's really beautiful, and our minds love it, and we get inspired to learn more about it, and it helps us understand. But there's a lot of deeper levels of healing happening here too, and I just want to keep that in the forefront of our minds here with this talk, okay? So we're looking at yin and yang, and that's the reason why I entered traditional Chinese medicine after being a pre-med student at the University of Minnesota. I thought I would be a doctor, but I got really disillusioned to Western science and the pharmaceutical industry and the way that medicine was being promoted to me. And so I kind of left medicine for a few years until I found Chinese medicine. And when I realized that there was a system whose fundamental principle acknowledged the shape of consciousness as duality, that no thing exists in this world without being in relation to something else, that it is all duality, that it is a yin and yang balance. And so when we talk about inflammation, we have this incredible balance happening in the body between inflammation being this critical piece of our existence and what keeps us alive, and then at the same time something that can rage out of control and can cause disease and lead to our death. So finding the perfect balance between yin and yang is essential, and that's where Chinese medicine is so beautiful, because you can take that yin and yang principle and apply it to every single system. What is the yin aspect? What is the yang aspect? Yang being, what's the kinetic aspect? What's the moving? What's the pushing, making things go? That's the yang element. And then the yin element is, how do we calm things down? How do we hold things and settle them, contain them, and make them feel at home? That's the yin part. And the two are balancing each other out in every single thing, every one of us, every second of every day. And the same is true in inflammation. Okay. Donnie's going to talk about the vagal nerve this weekend, and the vagus nerve, which is our primary parasympathetic nervous system, and so deeply connected into our GI tract, into so many of our organs. And when we talk about the organ networks and then the neurological network, the neuroendocrine system, for me it's all about the fact that the organs are where we're experiencing life. We're having this organic, guttural experience of life through the emotional body, this body that contains this emotional experience. But the emotional experience has gotten so incredibly deep and profound. There's so many layers that we have to have an incredibly complex neurological network to make sense out of it all. And that's a really beautiful thing. And it's something I also got from Chinese medicine, was that this system, this network of organs that we experience life through, we're metabolizing life physically, but we're also metabolizing life emotionally. And the two things are happening simultaneously. And the parallels that can be made there are many, many, and I spend a lot of my time kind of thinking about them in medicine, and how do we understand when the liver is dealing with toxins, what does that look like on the emotional plane, toxic emotions, and how do we work those through, and how are those reflected in the nerves that then take that information from the organ system and all the changes, all the chemistry that's happening there based on our emotional experience, and then refer that and relate that back to the brain, and then connect it through the switchboard back to the other organs, and so there's a communication and a dialogue with our heart to what we're feeling. That's an incredible process. And the vagus nerve, being this primary parasympathetic system, it's filled with efferent and afferent signals, outgoing and ingoing. And 95% of the signals going through that nerve are coming from our gut and our organ networks going to the brain, not going from the brain to those organs. So where are we feeling life? We're feeling it here. Where do we experience it? We're experiencing it here. And you can't overemphasize for your patient population the importance of the gut, the importance of maintaining the life that maintains us. And if we think about that GI tract as being a hollow tube throughout our bodies that's not actually in us, but that we root our cells, our columnar epithelial cells into, just like the plants do their roots into the soil. And then we tend and we farm and we shepherd all those microbes that live there, that interact with our nervous system to create the environment that induces the way we feel. How are we experiencing life? How much serotonin? 95% of our serotonin comes from the GI tract to influence how we feel, our mood. So all of this affects inflammation, in that inflammation is the signaling network that drives our immune system to protect us, to maintain the integrity of our self versus non-self existence. And without it, we would not be here. And the process of maintaining stability through change is this allostasis. Allostasis, this is the ability of the body to adapt continually in every moment to the changes that we're presented with. And it's we do it so well. Our bodies are so well equipped to do this. It's a constant adaptive process. So when we talk about inflammation, you think about the inducers of inflammation. What are they? Well, wounds, the first one, just somebody damaging the tissue, whether you get a bruise, you get a cut, blood vessels break, cells break apart, tissues are damaged, there's swelling, there's all the things that we know, all the cardinal signs of inflammation, pathogens, H. pylori, HPV, herpes. We've got all kinds of infections that rage in our bodies. And when I think about infections, I don't think that it's something out there that gets in here. I think of it as it's an imbalance in our flora. It's really we are an infection. I mean, we're full of bugs. So we're 10 to 1 microbe DNA to human DNA. So there's just we need to know that we are just completely microbes. That's what makes us up. And then we're a small portion of this part of us that we exist in, this human body. So when the things are out of balance, when an infection gets out of control, there's all this networking. The immune system is listening. It's just like we have our ears and eyes, but it's listening through chemical compounds. It's listening with its receptors. The cells are listening. They're listening, and they hear things like endotoxins, these things that are released, these lipopolysaccharides from the bacteria, from the invaders. The immune system picks them up, and then they go, what is that? I smell it over here. What is it? Oh my God, it's and then they go after it. And constantly this process is going on. And as soon as that signal is heard, then those cells release compounds. Things we're going to talk about, tumor necrosis factor, NF-kappa beta, the cyclooxygenases, these inflammatory mediators that drive other cells to hear those signals, to smell what they're saying. What is he saying? And then they come in and get involved. And suddenly you have this raging infection and the immune response to it. Chronic stress, inflammation and chronic stress is the topic of the hour these days, because our lifestyle here is filled with stress. We don't rest and relax. We don't just kick back. It's like, what are we going to do when we get old? How am I going to have money? How am I going to take care of my kids? Oh my God, am I going to get to work? I got to have the time. I got to have the food. It just goes on and on. We're constantly filled with stress, and those signals drive our body to generate more of those inflammatory cytokines, those inflammatory signals that drive our body into that yang state of action and drive it away from that yin state of calm, relaxation, rebuilding, and restoration. insulin receptor signaling. We talk about glucose. We talk about blood sugar and what this culture has done with diet, the SAD diet, and just the amount of sugar that we take in. It drives this inflammatory process. Gene mutations and alterations that are a product of our choices, our lifestyle choices. They're a product of our dietary choices. Our genes are affected, and over time they change the way that they function, what's turning on and off. We'll talk about epigenetics, cancer treatments, surgery, chemotherapy, radiation. All these things are huge inducers of inflammation. And again, without the inflammatory response, we would never handle a cancer. We'd never be able to fight it. No linear responses in this body. So we'll talk about the healing response, right? So when inflammation occurs, the body has to deal with the fact that there's broken material everywhere. There are cellular components that have spilled out into the surrounding areas, the cytoplasm is exposed, all kinds of cellular components, and the body has to get that stuff out. That's the first job of inflammation. Let's get all the junk out, clear away the damaged stuff so we can get in there and bring in new blood and start to heal the tissue and rebuild. But that process is it takes some time, and it takes a lot of energy, and it's often very painful. What do we do when we feel that pain? When we feel that, I sprained my ankle's swollen, it hurts, oh my God, I gotta get rid of the pain, right? That's not the right idea. Getting rid of the pain should not be the only focus. The focus should be like, how do I heal this? How do I help my body do what it's already doing? Because my body is already doing all the things it needs to do to clear out those damaged components and make room for new things to come in. Are we in this right slide here? Yeah, I was here. So intrinsic self-protection. And pathogens are a big part of this. When the pathogens are there, these big immune cells, macrophages, are phagocytizing components, eating up these pieces of the material, and they have to get that out. It's this constant process of inflammation driving the healing process. So the immune system, you can't separate inflammation in the immune system. You can't separate the immune system from the endocrine system. You can't separate the endocrine system from the neurological system. They're not separable. We look at them that way because, again, we're map makers. We like to lay things out in that way. But these are woven systems. Where they begin and end is indefinable. So, we're talking about preventing infection. We're talking about cytokines. Cytokines are the cellular signaling molecules that the body secretes in order to communicate with other immune cells. Things like interferons. Interferons are released in the body, like when you get a cold or a flu. It's the thing that makes you feel real achy. You got that muscle aches, and oh God, that's your body's response to the infection creating interferon in your tissues. You've got interleukins, like here I've got interleukin-1 beta. We're going to talk about that one a bit. Interleukin-6 and interleukin-8, very inflammatory interleukins, cytokines that tell other cells what's going on and to get involved. There's a fight that needs to happen here. That's more dealing with the kind of the heat feeling, the sweating, that kind of like that skin itchiness, or that feeling of like, God, I can't get out of my skin, and I'm hot and I've got a fever. The interleukins drive that fever, which is so important for the healing response. And then you've got the cells of the immune system, the white blood cells, the macrophages, the big phagocytizing cells, the cleaners, a cleanup crew, the granulocytes. These are the neutrophils, eosinophils, basophils. These guys have, little granules of different compounds that they hold inside their cells to be released when there's a problem, when there's an issue. And then lymphocytes, the T cells and the B cells, natural killer cells, dendritic cells, cells that have a relationship between the innate and the adaptive immune system, whereby they might either attack an invader or they might actually create an antibody. They might help to develop an antibody network towards an invader or towards a toxin. So I always talk about cascades and feedback loops when it comes to inflammation because, what happens, like I said, there's this signaling that happens, and once the signal gets going, it generates other signals. It's like a cacophony of signals that just start going. And when we see chronic inflammation and the way that diseases of autoimmunity develop, you see that it's that inflammation has gotten out of control. It's not stopped. And the inflammation drives the immune system, and the immune system doesn't stop. And so you start damaging your own tissues. Signaling networks. We're going to talk about the inflammasomes, kind of a newer area of research into the inflammatory compounds. These are big protein platforms formed inside of the cell structures as a way to kind of induce nuclear changes, make materials that then drive inflammation in a bigger sense. They also control the inflammatory response, helping it get going and helping it stop, creating that yin and yang balance in a perfect way so that it doesn't lead to damage to the host. It just damages the invader and helps to fix the tissue. And chemokines, just mention them a little bit because chemokines are compounds released by the immune system that regulate cell trafficking and adhesion. They help the cells, other immune cells, they say, hey guys, come over here, this is where it's going. So they release these. Those other cells are here, I hear the chemokine, I hear the call, the siren's calling, let's get over there. And then they get involved. All driven by inflammation. So we've got, we do have both pro and anti-inflammatory cytokines. So the immune system is also constantly developing ways to calm itself down once it gets excited. And that's just, I keep hitting back that yin and yang balance, how important it is. It's not that inflammation is bad and we need to get rid of it. Absolutely not. That concept is going to have to be just completely removed from medicine because that is not the way. There are moments where you need strong therapies to get involved to stop the cascade of inflammation which is out of control. That definitely happens. But in general, we want to find a way to use inflammation, to modulate inflammation in such a way that we create that perfect yin-yang balance and generate harmony in the body. This is just a little slide to show you kind of some of the things, the factors that get involved in regulating cytokines, genes, all the different diseases you see there, cancer, cardiovascular disease, infections, inflammatory diseases, autoimmunity. You've got things like bacteria, viruses, drugs, and stress factors all lead to the cytokine regulation. And again, inflammation is underlying this. Some of the big neurological compounds like glucocorticoids and catecholamines, these are compounds that definitely push the immune system in one way or another to either excite it or to calm it down. And these are things that, we talk about neuroinflammation, such a big topic these days, and another place where this yin-yang balance really has to be perfectly controlled. Just a little map of nonlinearity. You can just see here the overlay of pathways is very complex. You can't say, cortisol causes inflammation. No, you can't say that. Cortisol stops inflammation. Well, it does. It's a steroid. But it has, what if you have it in your body in high levels every day for a long period of time? It creates all kinds of changes in the tissue that lead to chronic inflammation. So it's just not as simple. I just want to make sure we understand it's just not simple. Inflammation is not bad. Inflammation is not good. Inflammation is essential. So when we talk about acute inflammation, I mentioned to you guys the idea that, what's the first thing you do? And of course we all know the idea is RICE, rest, ice, compression, elevation. You've got an injury. I think that's going to be changing as we go forward here. We've got to evaluate it a little bit further, but there's some great research that's been out there. I know that the Cleveland Clinic did some research showing that when you ice an injury after, when you first get the accident happens, you actually slow down the healing process. They looked at a bunch of people, they watched them, they put ice on their wounds, and their wounds healed slower than people who got heat. Chinese medicine has always known this. The whole concept is heat treats heat. And again, the reason is because we're afraid of pain. And inflammatory mediators drive those nerves to destabilize. The destabilization that occurs under the influence of all these different stressors in our life cause systems to become unstable. When systems are unstable, they react really quickly. So the neurological network is sitting there listening, and as soon as those inflammatory mediators get going, the the neurological system starts sending messages. Oh my God, this is intense. Something's going on. This is bad, and you feel pain. So then we need to be able to deal with the fact that the pain is a part of the inflammatory response, right? You've got the redness, you've got your heat, your calor, your rubor, you've got your tumor, your swelling, you've got your dolor, the pain. They're all important. They're all a part of it. Prolotherapy, right? You guys know about prolotherapy? The proliferation therapy, it's an old Greek way. The javelin throwers would throw out their arms. They'd always damage their ligaments, and so they found out back in, this was like in the AD 400 or something. They learned that if they took these I don't know what they made them out of, some kind of bronze or something, but they had needles and they actually poked them into the origins of these ligaments, and they would damage the ligaments, and then the body would send in a new healing response because the initial damage wasn't so strong in these kind of low vascular areas that the body didn't get going as much. They didn't really take care of the damage. So they would injure the tissue, and then the damage would be started up again. The immune system would get involved, and all this blood would move again, and you'd get healing. So now we have a more elaborate system of how we work with that, but again, just showing you the importance of inflammation in the healing process. So chronic inflammation, this is persistent dysfunctional inflammatory response over long periods of time. Tissue damage, cellular damage, predisposes people to autoimmune conditions and other diseases. It's so many different things, from atherosclerosis, arthritis, rheumatoid arthritis, psoriasis, COPD, cancer, stroke, chronic pain conditions. So many things are a product of chronic inflammation. And like I said before, chronic stress drives chronic inflammation. This is just I really like this model, again, this is looking at the inside of a blood vessel. You have the lumen up there in the top, and you've got the outside of the blood vessel here, the adventitia, the outer layer. Here's the media. This is the endothelial lining. And you can see what happens over time. These are the different stages as this is developing. And again, we have LDL cholesterol here, which we know has a role to play. And this is oxidative LDL, right? It's oxidized. So when we look at cholesterol, and we're trying to think, well, how much do we need to control cholesterol in people? We know that there needs to be a balance. But cholesterol is not the issue driving this process. It gets woven into the process. But inflammation is the driver for this process, and many different aspects. And these are immune cells. These are big macrophages that are eating up these oxidized low-density lipids. They're low density so that all these different interactions can happen with those lipids, and they can break apart and become other little pieces and fragments that can then build up in the body. So the macrophages eat them up, but then they get swollen and they can't move and they become fat, and it looks like striated meat. They call it looks like marbled steak in there. And that's what happens. But again, it's inflammation that's driving this. So some of the key inflammatory pathways, NF-kappa beta, that's a big driver. I mean, it's found everywhere, and I'll talk about it in more detail because it's a major driver of the inflammatory process. It mediates gene expression. It's very, very important. Big driver in the immune system. The second one there, TNF, tumor necrosis factor. It's a glycoprotein. It stimulates immune responses. You have cyclooxygenase, generally cyclooxygenase 1 and 2 we're going to talk about. Lipoxygenase, that's LOX, and then the interleukins and the prostaglandins, the eicosanoids, of which there's a class of those compounds that all are elevated during the inflammatory response. So what kind of conditions are we talking about being mediated by NF-kappa beta and TNF? Well, there was the picture we had of atherosclerosis. And remember, calcium is a big player in there too. Hardening of the arteries is a part of that. It's those oxidized LDL particles, the immune cells, the inflammatory process, reactive oxygen species, and then you have calcium as well. So everybody running around eating extra calcium all the time, it's not such a good idea, folks. It's like, we get a lot of calcium, and our bones are full of calcium. It's about how we use it, not how much we eat it every day. So be careful with calcium supplementation. Just enough is the right amount. Arthritis, RA, IBS, cancer, stroke, Crohn's disease, ulcerative colitis, so many things driven by NF-kappa beta and tumor necrosis factor. And I'm going to show you kind of how those two things interrelate. And again, now we're back to the maps, and we're back to the concepts and these molecules that we've named. We've never seen them. We've just mapped them. Again, remember, there's no camera there watching these processes happen. This is all coming from our story. So NF-kappa beta, the master inflammatory switch, regulates genes, plays a role in diverse biological processes, activated by TNF and interleukin-1, and also activated by oxidative damage. So when our body fails to quench the free radicals cause damage. And that damage that they're causing and the signaling that they're creating is driving these inflammatory mediators to create change at the nucleus and to change the way the cell communicates with other cells. And the cell starts telling other cells to get excited and to get involved in this, again, yang process. Increasing cyclooxygenase expression, both of these things. Here's NF-kappa beta kind of sitting in the middle. Stress, diet, chemotherapy, infection, obesity, addiction, all things that drive NF-kappa beta. Chronic stress, again, driving this factor. And what does it do? It drives these, it creates in the nucleus, the cell creates more interleukins. IL-2, IL-1, IL-6 creates TNF, which is driving NF-kappa. That's the feedback loop cycle. Things that this leads to, cachexia, anorexia, fatigue, depression, so many diseases and disorders, the product of inflammation that's raging out of control. So here's some other factors around NF-kappa beta. You can see here some of the key activators: oxidative stress, genotoxic stress, innate immunity. Those are the DAMPs, those are the damage-activated immune cells. TNF family, tumor necrosis factor, these things all, again, with aging, these things that get out of control, like that we no longer have the adaptive and allostatic response to maintain, they're driving the NF-kappa beta. And you see the green arrow here shows that this is green. It's given the green light to make more of this, which then leads to more of this, cycling, and leads to more of this, aging, age-related diseases, neuronal degeneration, and cellular senescence. The other side of it, you can see there are the sirtuins. Those are compounds that are involved in telomere stabilization, which keep our cells replicating in an appropriate way over long periods. You've got things like tumor suppressor genes there. And you've got also the hormetic chemicals, phytochemicals. And hormesis is kind of that concept that comes from, plants make compounds. That's how they deal with the world. They can't move like we can, so they have to just create chemical compounds all the time, which is really beautiful. That's why we love mining them for this information they give us. And when the plants are making their own phytochemicals to prevent an infection, to maybe dissuade a predator, they make big amounts of these phytochemicals that we know as phytoalexins, the things that we know as medicines. And when we take them into the body, it's a much smaller effect on our body. The amount that we take is a smaller amount, and what it does is it starts to act as like a signal and a trigger for the immune system to get involved. It makes small changes in the body. It changes the way that networks work. And it's really beautiful and complex, but it's part of the plant medicine, that these hormetic pathways activate systems in the body and like control NF-kappa beta, for example. So just to talk about cancer a little bit, I'm going to be hitting cancer tomorrow and Monday, and mostly that's going to be about trying to help us all understand that we can really be supportive to people going through cancer. There's a lot we can do, and you don't have to know everything that Donnie knows to deal with cancer. We can help people in a lot of ways, and so that's why I wanted to bring that to light. And working with Donnie for the past 12 years, I've learned a lot of what Donnie knows, but I want to try and make it a little bit simpler and really hash out some of the stuff that's complicated. And inflammation is such a big part of that process as well. So here's just a little idea. You can see tumor necrosis factor. It used to be called TNF-alpha. It's being driven by all kinds of factors in the body, all these signals I said before, trauma, everything we talked about that drives inflammation. That's leading to an upregulation of the TNF-alpha receptor, which is a receptor activator of nuclear factor kappa beta. These are things that work to induce NF-kappa beta to be released. And when we talk about NF-kappa beta, you have to understand that this is a compound that's stored in the cytoplasm of the cell, and there are these molecules that are called NF-kappa beta inhibitors. It's called IK beta, and these molecules work together to pack the NF-kappa beta nuclear factor, right, which goes into the nucleus and drives that inflammatory signaling system. It's all being packed into these little, kind of groups of molecules that are being held by this inhibitory kinase, I-kappa beta. And when the TNF gets signaled, or other receptors get signaled that also are triggers, that inhibitory signal starts to break down, and the NF-kappa beta is released, and it goes right into the nucleus, and it starts to drive transcription in the nucleus. It starts to create all kinds of interleukins, for example, that are inflammatory, that the cell then generates, sends out of its own environment and out into the ecosystem around it, so that it induces the same response in other cells. So NF-kappa beta is really, really important, and the reason I'm hitting it hard is because so many of our plant medicines modulate NF-kappa beta activity. There's so much data. It's beautiful. Start digging into cancer and plants, you'll see NF-kappa beta is everywhere because it's so important. One of the things it does is it controls cell death, apoptosis. It also influences the way that cells survive or don't survive. So you can see there, this back to inhibition up here. It inhibits the apoptosis that would naturally be occurring from part of what TNF-alpha does. A lot of these compounds, these inflammatory compounds, have an influence on cell survival. And in cancer, of course, cell survival is a big deal. And we want apoptosis to be happening in cancer cells. That means we want cancer cells to be recognizing that they are dysfunctional and they should be shut down. They should take themselves out of circulation. That's our network. That's how our body works. And the immune system, tells the cell, hey, you're broken. Let's take you apart. And that won't happen in immortalized cells that have all this NF-kappa beta driving them to survive. Let's see.
Jason?
Yeah. Oscar.
On that last slide, is it correct to see that TNF-alpha both initially can cause apoptosis, but in the long run, via NF-kappa beta can inhibit it. So
Exactly. Exactly. Oscar's bringing up this diagram. That what's interesting about it is that you can see that TNF alpha is part of the yin and yang balance in the body, and over time, and if it keeps driving that NF kappa beta, its natural process of creating apoptosis through that signaling network, it gets inhibited. So it's inhibiting itself through NF kappa beta. And so it's a paradoxical nature. It's this yin and yang balance occurring. Exactly right. I think I've lost my little pointer here. Maybe it's dead. So just kind of talk about the TNF is a big factor. It plays a major role in autoimmune disease. And what happened is the FDA approved these 3 drugs in the around 2005. Enbrel, etanercept, Remicade, and Humira, which I'm sure you've all seen and heard. Humira seems to be the drug of choice these days. If you have a rheumatologist in your midst, he'll be prescribing a lot of that. And it's funny because 10 years ago it wasn't the same way. It was like methotrexate, maybe leflunomide, and then down the road it became Enbrel. And then now it's like, Humira. The Humira is the only way to treat your disease. It's like, well, what do you mean? It's the only way to treat the disease. I mean, you mean like you just learned how to treat it like just a couple years ago? I don't understand. I thought you've been treating it a long time. But my patients come to me with this because it's very, the rheumatologists are very happy with the drug and the results of the drug because it does do its job. It does. What it is, it's an antibody. It's called a monoclonal antibody, meaning it attaches itself to a specific antigen. You know what that antigen is? TNF, tumor necrosis factor. So what happens when that antibody sticks to that antigen? Well, it neutralizes the TNF and it becomes a complex that then the body takes apart and gets rid of. Well, what's the problem with that? The problem is that TNF has a lot of roles to play in our body. It drives our immune system. What does our immune system do? It keeps us alive from getting infections and keeps us from getting cancer. That's why one of the main side effects from Humira, 1 to 2% of all people get leukemia. You talk about first do no harm. My God. I mean, I need some help with this pointer from one of the wonderful technologically savvy people. Thank you, brother. There you go. So some of the natural compounds that suppress tumor necrosis factor, these are some of my favorite ones, and some of the ones that just have a lot of data. Andrographis, a Chinese herb. We'll talk about it in more detail. Atractylodes, macrocephala, boswellia, that's our frankincense. Uncaria tomentosa, cat's claw. Curcumin, feverfew. These are things that we can use. And again, these are modulators of inflammation. They don't just stop inflammation from happening, they modulate it. I put the plants on the left side of the slide there. And the plants are, and curcumin be really, curcuma longa, that's what we're talking about here, turmeric, and then feverfew. And then on the right side I put more compounds, so epigallocatechin gallate, Walter. Oh, wow, great, thank you so much. Wow, that's fancy. Cool. Epigallocatechin gallate, right? Our main catechin from green tea. The isothiocyanates, from broccoli seeds and cabbage and wasabi rhizome. Those are sulfur-rich compounds. Resveratrol we know from wine, so much from the skin of grapes and the seeds of grapes, but also in the Polygonum cuspidatum, the tiger cane. Scutellaria bicalensis and its compound bicolin, white willow bark and the salicin, the salicylates there, and then thymoquinone from black cumin, Nigella sativa. Just some of the big compounds I'd like to hit on today. Let's see. Yeah, I want to talk about something called the inflammasome, and I mentioned it before. The inflammasome is the way that the body organizes this yin and yang communication of inflammatory signals. The primary driver is somebody called interleukin-1 beta, and there's interleukin-1 alpha, but it's an interleukin, so it's made in the nucleus of immune cells to communicate with other immune cells about getting excited, about dealing with a damaged tissue, getting rid of a pathogen, etc. So these are bigger signaling platforms that exist in the cytoplasm of the cell, and they network themselves together in response to chemical mediators. And a lot of times it's toxins from the environment. It can be things like heavy metals, for example. Could be, I'm using this one here just because it's working, but I don't have a clicker. I don't have a slide mover. He took it, that nice gentleman. He was one of the tasers, I think. Watch out, he might have a taser on him. Yeah, see. So, the innate immune system here relies on the inflammasome, because it has the capacity to regulate both those pro-inflammatory responses and anti-inflammatory responses. Again, just tightly controlled network. And this is kind of one of these things that's coming out in the literature more, is the inflammasome. So all these plants that are going to be targeting NF-kappa beta, they're going to be targeting interleukins, they're going to also work with the inflammasome. And although there's not a whole lot of data on plant compounds and the inflammasome yet, we're going to see a lot coming through in times to come. So caspase-1, caspases are another signaling compound that drive intracellular function. You can see here that mature interleukin-1 stimulates NF-kappa beta, right? There's that transcription factor again. It plays an essential role in auto-inflammatory conditions, autoimmunity, cell death. It also contributes to autoimmune inflammation. So interleukin-1 beta, when it's not regulated, when it's not modulated, it starts to lead to damage to the tissues, and this inflammatory process goes on and on. So why isn't it that we can't just, shut down the inflammatory response, just get it to calm down once we have an autoimmune disease, right? Because we've got all this great information, and we've got all these great medicines and plants and even drugs if we need them. I mean, why can't we just stop the autoimmune disease by shutting down the inflammation? Does anybody know? Anybody have a guess? There's a lot of brilliant doctors out there. You got something? Oh, hey, laser. I've got someone back there with their hand up. Yes, sir.
In terms of shutting down the inflammasome molecule, they do have to target caspase-1. No genosinocydes do that very hard.
So he was talking about shutting down the inflammasome as a part of this. I'm thinking more on just a bigger level. I mean, that's great, but how do we actually get the autoimmune response to stop? How do we cure rheumatoid arthritis? Michael?
You need to address what's driving apoptosis in the first place, the cause. So if there's gut issues at play, there's sensitivities, toxicities, you've got to address those.
Absolutely. He's saying you've got to pull out what I call the insults. That's a big piece of it. Whatever's driving the body to get into this process, what's starting the signaling cascade to go, we got to pull those things out. That's one of the big parts of the process. Yes?
Well, you're talking about autoimmune disease. You have to move things from the Th17 state, driven by IL-6 or IL-17, over to a Treg state. So you've got to activate IL-10. Things that do that are vitacalin, tangenomes from salvia.
Yeah, he's mentioning that you can also calm down the inflammatory response by moving away from the Th1-driven inflammatory cytokines into the IL-10 and other interleukins that calm the inflammatory response more, and using things like the tangenones from Salvia miltiorhizome and also bicalin from Scutellaria. Those are absolutely true. I'm thinking more about the fact that what's happened in an autoimmune disease is that your body has identified self as non-self, right? So a part of you has been tagged as an antigen. What does that mean? It's an antigen is an antibody generator. That's what antigen means. This is a compound that generates an antibody. So your T cells find that thing, they grab it, they bring it to the B cells and say, you guys, this thing again. They're like, oh great, we got antibodies all day for that. Hold on, I'm going to shift over here, plasmacyte, boom, I'm just going to dump a bunch of that antibody into the bloodstream. Got it. It hooks up to that antigen. Now we've got antigen-antibody complexes stick all over the tissues. We clean that up, and then there's more. And it keeps going because you know what? It's you. It's your knee. It's your cartilage. It's your bone. It's a part of you. So how do we get that to stop? And that's really the trick in all of this. And so when you do, like what the gentleman in the back was saying, if you do calm all this inflammation down using plants, using whatever agents you need to, the signaling gets quieter. When you pull away all the insults to the body, whatever created the problem in the first place, that also comes to quiet the system down. We meditate, we do Qigong, we stop the stress response, we do everything we can in the person to stop generating whatever the initial signal was. And it takes time. And when I do an autoimmune diet, I call it a very tight diet. It's very tight. It sucks. I've done it for 6 months, I know. But it works. If you combine all these therapies together, we can stop the body. So eventually what happens is the body somehow can de-recognize that part of itself. If we could find out how to actually, just really go in there and tell the body, hey, it's okay, this is me, it's all good, that'd be great. But we don't have a way to do that yet. We have to just basically calm the system down enough that over time that process slowly stops, goes away. Like in thyroid disease, like Hashimoto's, a lot of people have gluten issues, right? Where you have the gluten molecule, looks very similar to the TPO molecule, so there's this process. Every time the thyroid's making hormones, the body thinks it's part of this non-self, and it attacks that with an antibody. Every time you take an iodine, it drives that process of making thyroid hormones, and then you've got this TPO being made, and the body attacks it again. That's why when you give someone thyroid hormone, their thyroid stops making TPO, so the body stops attacking it. But it doesn't fix the problem. It just put this sort of like said, hey, we're not going to make the thing that the body's reacting to. The body may stay in this state of destabilization, and as soon as you pulled that thyroid out, it would go right after that TPO again. That's not fixing the problem. It's dealing with the symptoms. And we do that really well. We can deal with symptoms, but we need to get better at getting rid of the cause. And so it's a very multifaceted plan, and that's for another lecture. But I just wanted to bring it up because I think it's a really interesting topic. Yeah, Michael?
Do you use any protomorphogens to help with the...
I don't. Like stuff from standard process? I have in the past. It's a good concept, though, and a good thing to talk about, but not quite here at this moment. So what does IL-beta do? Again, here it is. It drives NF-kappa beta, which then drives the genes to make more of these interleukins, the chemokines, just drives the immune system to get going. It pushes that yang element, that yang aspect of the immune function. So let's look at a couple of plant compounds. Curcumin, that's the main curcuminoid in turmeric, and resveratrol. These two plants work really well together. These compounds work really well together. In this first study, you can see the suppression of IL-1 beta. That's happening mainly by its activity against NF-kappa beta. Again, kind of controlling that release of NF-kappa beta in the cytoplasm, getting those inhibitors to work better, and just stopping that destabilization from happening so that NF-kappa beta doesn't flood into the nucleus and get the cell going again. That's what these compounds can do. They work really well together. Cocktails of curcumin and resveratrol directly suppressed IL-1 beta. And this study, I'll admit, these are in vitro studies, so they're just kind of preliminary. But we have seen some other things. Again, like I said, the inflammasome stuff this is kind of newer to me in the research setting. So we'll see this stuff all going into animal studies. We don't see the research on our compounds get very far because why? Because you can't patent a plant. If you can't patent it, you can't make millions of dollars on it. So how are you going to spend millions of dollars to study it? Nobody wants to fund it unless they have a lot of money to make off of it. So that's why our plant medicines don't have a lot of good data on them. So that's why we rely on traditional usage as our primary evidence. And we're going to talk a bit about evidence. I think it's tomorrow, actually. Jerry Codd and myself and David Winston and maybe Jill, I think, is somebody else on that panel. But we're going to talk about evidence and what is evidence and what constitutes evidence. And we're going to get to a little bit into the idea that this is a subjective world. This is not an objective world. You cannot objectify this subjective world. We can do our best to do so, but it doesn't ever get to the point of true objectivity. And we're going to flush that out a little bit for you guys. I really like the clicker. Darn. COX and LOX. So chronic activation of COX provokes all kinds of diseases. You guys know about these pathways from aspirin, from acetaminophen, from ibuprofen, from meloxicam, from all these, NSAIDs, non-steroidal anti-inflammatory drugs that inhibit the cyclooxygenase pathways to reduce inflammation. And they're very powerful in that way. They block these pathways and they shut down that part of the signaling system, and often they're very effective for relieving pain. But again, when you have that ankle sprain and you want to heal your ankle, or you got that at the beginning of your flu or cold. I don't know if you guys remember that product Theraflu. Remember that? People used to take Theraflu. God, they'd be sick for weeks, but they feel fine most of the time. And then they feel sick, and then they feel fine, and they feel sick, and then it never get better. Why? Because they never let the process unfold. So when you take those NSAIDs again, they're just suppressing the inflammatory response, suppressing it. When you take plant compounds, they don't suppress it. They help your body use it. They help the body get better at clearing out all that stagnant material. They help the body get better at repairing. They help the immune system signals, be better at calming each other down and exciting each other. It's like, it seems like magic, but it really is natural. These are things that are familiar to our body. Lipoxygenase is beautiful. It modulates the leukotrienes, these compounds involved in cell damage that direct, vascular constriction, and also these hypoxylins. These are compounds that also get involved in tissue permeability and so forth. That when we have damage, these other systems get upregulated. Especially fibrinolysis, the building of a clot and the clotting cascade. All that's driven by inflammation too. They're coupled. These systems are all coupled together. And LOX is a place that our plants work really well. Some of the plants I'm going to talk about today are really nice as they hit the lipoxygenase pathway really hard. And in a lot of cancer cases where we're not dealing with trying to heal a wound or an injury, we're trying to stop the cancer from growing, we can combine the plant medicines with NSAIDs or with Celebrex even in some cases. And that can be a really powerful way to get the lipoxygenase and the cyclooxygenase to work together. And we'll see why. Because both of those pathways interact with arachidonic acid, which is part of the phospholipid breakdown. So when you eat something that's rich in meat, basically, you break down those the products of the cell membranes, and you get all this arachidonic acid, which then is which is then acted on by LOX and COX to make the prostaglandins downstream, which then regulate inflammation. So I just want to show you how that works. You can just see here's an idea of what I'm talking about. So when you target LOX and COX simultaneously, you're really modulating both sides of this. And the plants that do a really nice job. Again, they don't just stop it. They have an inhibitory effect on it being out of control. But they don't shut it down altogether. If you shut it down altogether, then you don't get any of this downstream stuff, which we still need for healing. Same thing goes over here. And a lot of our plant compounds target this too. But we have these drugs, these over-the-counter agents that target those, like I said, in cancer. And you can see there, one of the things that happens when you take NSAIDs, everybody knows that what's the primary side effect? GI damage, right? And you can see here, because these prostaglandins on this side are GI protective. So when you stop them, completely inhibit them, well then you're not GI protective anymore. Now the role of that inflammatory signal that triggers those cells of the GI tract to make more mucus and protect the cells from its own acids and digestive cocktail is no longer there. So it's not, again, we're not trying to suppress the body's process, we're trying to enhance it. And on this side you can see the gastric damage is actually a result of this process. So when you inhibit LOX, you're actually helping I think I'm just breaking technological things today. Walter, I'm sorry, it's dead. I don't know what it is. Okay. Maybe we should just turn this thing off. Let's go freeform? I don't know. All right, here's just another look here. You can see some plants here that affect these directly. Boswellia, ginger on the right side with lipoxygenase, and the curcuminoids, and ginger again, the oleoresins, zeramburone, with great compounds in ginger, and bromelain inhibiting the prostaglandins more directly, and the thromboxanes involved again with platelet aggregation. Just kind of want to flush that out for you guys, and all this, of course, joint soreness and stiffness from these inflammatory pathways. We talked about epigenetics, right? Effectors leading to epigenetic change. I think Walter pretty much crushes this one. And you can just see that epigenetics is not. We're not talking about the SNPs. We're talking about all the other factors that play into how the SNPs express themselves, right? So the way that those compounds that the genes code for, every gene codes for a protein. That protein has a function, whether it's an enzyme or a building block. And so when those genes are signaled, they're triggered to do their job, they're supposed to do it in a certain way. But that certain way isn't set. It's actually formative, and it changes over our lifetime, and it changes through our offspring. It changes based on the choices we make. And then epigenetics are different factors. The way that the molecule, the DNA, is held together. How close is it? How far? The way that histones deacetylate or acetylate and package that material. All those factors influence the way that those genes work, whether they're turning on and they're producing a lot of their protein or not producing much of it at all or producing none of it. And this is where we get into epigenetics. This is why 23andMe and everybody looking at their genes is so fascinating, and it's amazing, and it's important. But again, guys, the map is not the terrain. You can't just look at a person's 23andMe report and, just decide what they need to take or not take, what they need to eat or not eat. It doesn't work like that. Every gene that's on or off is in relation to every other gene that's on or off. And some of the relationships are strong and some of them are weak. But we don't have a clue as to how they work. We could say that you're a caffeine metabolizer, slow or fast, based on your SNP, your CYP enzyme that basically metabolizes caffeine. But how does that relate to why your body does it slow or fast? And what are the other factors? Or methyl tetrahydrofolate reductase, right? Everybody's talking about methyl tetrahydrofolate reductase, and take folic acid, take the methylated form so you can skip all the parts that you need to go through to get to that place. Well, why do you think the body's doing that? I mean, you think there might be a reason for it, or is our bodies are just these dumb sort of, robots that walk around and just sort of, I don't know. I don't even understand what the concept is, but there's a reason for these things, and I think we keep playing with it, and we don't understand what we're doing. That's why, again, back to plant medicine, and why are we here? Why are we all here talking about plants? Because they don't work in a linear fashion. Because we understand them at a macroecological level. We look at the energetic nature of the plant. We apply it to the energetic nature of the person, and we find that it works. It's a gift. We don't have to turn plants into drugs. We shouldn't turn plants into drugs. So our health is not determined by our genes per se, but their response. I kind of already went over this. Many botanicals are able to calm the inflammatory response through their dynamic interaction with epigenetic and immune systems. That's really important. That it's just, when we talk about the plants and how they regulate genes, it's not always, whether they regulate inflammation, or they regulate genes, or they regulate the immune system, they're doing all of it. They're working on all of them. And so when you see a research study, plant compounds, and turn on this gene or turn off that gene, it's just part of the story. And a lot of the plant compounds that we have, like we talked about the isothiocyanates, the sulfur-rich compounds from broccoli seeds and cabbage sprouts and wasabi rhizome, and these watercress and other things. These are compounds that turn on tumor suppressor genes. They strengthen those genes that kind of oversee genetic replication. There's checkpoints. When our cells are replicating and the genetic material is being reproduced, there are places along this long genetic thread where the body says, okay, is everything good up to this point? Are we okay? Are there any mutations? And those checkpoints are really important. So certain compounds, a lot of our plant compounds, and especially those isothiocyanates, they help those checkpoints to stay strong. So that if an error is occurring in that genetic sequence, that checkpoint says, no, we don't replicate this cell. We start over, or we end this cell line. And that system and that process is so important for us in these times with the amount of stress and the amount of toxicity that we're facing. So we can't overestimate how important it is for our medicine to work in prevention of disease. So let's get into aging. Immunosenescence. As we get older, right, we know that a lot of things don't work as well. The way that our immune system functions, it's not quite as strong. The way that we control inflammation isn't as strong. You actually find that inflammatory mediators get elevated in older folks, and as we get older, we find that our ability to quench free radicals, our ability to shut down the breakdown, this process that's signaling our body to fall apart, we lose the ability to quench those signals. I mean, just being here, just the way that we metabolize life, the way that we have to take sugar in the presence of oxygen, our fuel with oxygen, we burn it, right? Inside of each of our mitochondria, we're basically creating a reaction to build ATP that then drives our body, the currency of chi, ATP, to push our body to do things, to replicate more cells, to build new tissue. That process costs us. It costs us. We have a little fire, a furnace inside of every single cell in our body. Every mitochondria is a furnace, and that furnace has an insulative protective layer around it. It's the superoxide dismutase. It's the peroxidase enzymes. It's our glutathione and thyroidoxin systems that quench the free radicals as they're being broken down, as the fire is hot and burning to create the life force and bolt the heat into our bodies. This process needs to be controlled. And that control starts to break down as we get older, as we become drier, as we become more fragile. And inflammation is driving this. We lose the yin aspect, the control of the inflammation, which drives this process. We lose that ability to quench and to insulate the inherent reactivity of our life force here. Frailty, sarcopenia, cachexia, these are all things that develop when inflammation is not controlled in the body. I want to ask you guys a question. Does pain equal inflammation? Does inflammation equal pain? Who said no? You said no?
I'd say no, yeah.
Could you tell me why?
Well, if you don't have pain and temperature nerve fibers, you might not notice pain because you have inflammation.
Okay. So he's saying that you could have inflammation that was like sub-activating and you didn't really have pain? I like that answer. I didn't think of that. What about, can you have pain without inflammation?
Yes.
Can you guys tell me when? What is it? Childbirth. There might be a little bit of inflammation happening at that time.
Phantom limb?
What's that?
Phantom limb?
Phantom limb. Phantom limb. Phantom limb pain. That's a really good one. Emotional pain. I like that too. I wonder at the cellular level. Yeah, and that, I'm talking about physical pain. I think that's where I should have specified. Emotional pain obviously can exist, separately from this body and pretty much entirely. I mean, it's going to show up in the physiology, but you're right. Emotional pain. I love these answers. I love it. Thank you guys. I just learned a lot. Thanks. I was mulling this over in my mind, being like, God, well, what, eosinophilia? I don't know. When is pain, when are pain and inflammation not coupled together? I think it's really interesting. So you've got lots of different kinds of pain, neuropathic pain, dull aching pain, burning, sharp stabbing, pulling, spastic. This is where it's not like we're just, you have pain here. Opioids work for pain. We'll just give you some Oxycontin, right? I mean, it just shuts down the pain response. But when we look at pain from the herbal medicine perspective, we're looking at, well, what kind of pain is it? And then we can apply plants that are natured to fit that kind of pain. I asked a couple of the herbalists here, David Winston and who was it? It was last year, Southwest, I think. Paul Bergner. I was like, hey, you guys, well, so what do you guys think about pain and herbs? And I think one of them said, oh, yeah, I asked 7 people Paul said, yeah, I asked 7 people, what would be the first herb they would choose? If they had one herb, what would they choose? And almost all of them agreed. Jamaican dogwood. Pisidia. It's pretty cool. Kind of for a broad range of pain. So when we talk about botanical modulators of inflammation, we're talking about, again, the ability of plants to help the body keep inflammation at just the right level. And what will happen is that, these herbs are very good at relieving the pain. And I think a big part of that, is that the process of getting all that damaged material out of the inflamed area, herbs are so good at helping the body do that. And in a lot of the Chinese medicine herbs that are anti-inflammatory are herbs that come from a category called herbs to remove blood stagnation, herbs to promote blood circulation, and herbs to break blood stasis. It's kind of one category with 3 different degrees. So herbs that promote blood circulation, like turmeric, for example, herbs that remove blood stagnation, like Salvia miltiorhizome, and herbs that crack blood stasis, like sparganum, like hirud, like one of the herbs. I mean, it's very exemplary of that class is actually the leech, which is rich in hirudins, and hirudins actually inhibit clotting. They work very much like heparin. And so when you think about breaking up blood stagnation, and you talk about the way that inflammation is coupled to fibrinolysis, right? Fibrinolysis, so the building up of fibrous clots, the calling in of fibrous material, and then the aggregation of platelets together, all that's part of the process as well. And they're coupled. So inflammation's coupled to clotting. And so the plant compounds that work at that level where they're just breaking up the stasis, they're inhibiting those clotting factors. I don't know if you guys heard, but there was a really interesting case that came out of New York just about a couple weeks ago, and a patient actually died. He was under medical care of, I believe it was a naturopath. I might know. Actually, you know what? It wasn't that. He was working with medical doctors, and he had on his own, and he had a condition, and he took curcumin, pretty good dose of curcumin, and it was really interesting because he was in the hospital and he had a bleed. He had a bleed, and he died. And they tried to figure out where the bleed came from. And they went back and they looked through his medications and all the things he'd been taking, and they found that he had been taking a substantial dose of curcumin, self-prescribed. And they came to the point that they felt that the curcumin was the cause of his death. That the curcumin's effect on factor 10A, factor 1 or 2, was influencing the clotting cascade to such a degree that it influenced his bleed. Now, whether or not we know that's true, I mean, you can always look at these things, but you can't always create causation out of it. But it was an interesting case because, it just showed, well, once again, I mean, these are the medical establishment says that plants don't work. Right? They don't really do anything. And they're dangerous. Well, they're definitely very dangerous. Look, I mean, yeah, exactly. How does that work? How can you not work and be dangerous at the same time? What's the story there? I don't know. So anyway, that's a really interesting case. But if we get back to the plant compounds that inhibit inflammation, they remove blood stagnation. These are anti-inflammatory, and I don't even like to use that term. What's anti-inflammatory? I mean, these are drug terms. Plants are not anti-inflammatory. Plants are going to help the body use inflammation in the most appropriate way. So, whole herbs versus isolates, we like to use both. Targeting multiple pathways. Herbs are multitaskers. They do lots of things at the same time. Remember, we're talking about one herb being how many compounds? Hundreds of compounds. And then you combine how many herbs in a formula? Maybe 8, 10, 12 herbs in a formula. How many compounds you got now? You got thousands of compounds. Maybe you're using 3 formulas. Maybe you're using tens of thousands of compounds. Hey, Jerry, can I get the biochemistry on that? Tens of thousands of compounds. How are they all working again? Yeah. Anyway, but it works, and so synergy, creating synergy by using lots of different things together. And, there's been a lot of folks, especially in the botanical medicine field, that have believed strongly that giving people many different plant compounds simultaneously gives you lots of a little that all kind of helps together, and then you sort of avoid too much of any one thing. If you start concentrating a compound, like if you take a plant and you isolate it down to 50% of one, you want to standardize it to, like, let's say we're talking about andrographis. We want 50% andrographolides, those diterpenes in that plant that are so powerful for their inflammation control. What else did we do when we concentrated that? That's where it gets interesting, because we don't understand. We just isolated out a whole spectrum of that plant down to this 50% of this one thing. So we also must have caught some other things too, and we just don't have all the data. We're getting data. We're understanding these things. But, what I always try to do is keep a lot of the whole plant present with whatever compound we're using. I was having breakfast with some nice gentlemen from, what's it called, Vital Plant. I think this is a company I hadn't noticed before, but they were talking about growing herbs. And another guy here, Niall, I just talked to, he's farming herbs. And we're talking about how do you keep, in a farming setting, how do you keep plants producing the phytoalexins, the compounds that they produce naturally when they're under stress from fungus or local bacteria or whatever it is? How do you keep maintaining that in the farm so that you get them to make the resveratrol or whatever it is that you want them to make, right? And one of the things is you've got to keep making the stress occur. And if you created a situation where you had kind of a controlled environment where you could say, well, it's this fungus that generates this response in the plant that makes resveratrol just so hyperpresent in the plant. So let's say, okay, I'm going to start growing this Polygonum cuspidanum, and I'm going to just infuse it with this fungus, and it's going to grow like huge levels of resveratrol. That would be awesome. Please do that. Somebody do that. But in light of doing that, because it's hard to do that, I will take an isolated resveratrol and I'll combine it back with the hujan, with the Polygonum cuspidanum, put them together, so that you get the isolated extract, you get that high potency of what I really want to focus on, the regulation of NF-kappa beta, the control of tumor suppressor genes, all the things that we know resveratrol does, regulation of glucose and insulin, blah, blah, blah. And then I combine it with the rest of the plant so that it works in a way that the body recognizes it. So, putting these things together, creating synergy by combining compounds. So we have the difference in the perspective. The one is, let's use a lot of a little bit of things so that we don't ever get into that kind of toxicity level or, using plants like drugs. The other side of it is we have severe diseases, we need lots of influence. Let's use some isolates and let's start going after things more specifically and use our scientific mind to get smart about it. And somewhere in between, there's a way to make it all work. And I think if you keep the orchestration happening of those plant compounds that are regulating and helping the body do its job, and then you use these isolates in the right amounts in the right context, you can get a lot of synergy happening, and we can start to see things, severe diseases be controlled in ways that we hadn't been able to before. Question in the back?
Yeah. Well, there's a place in the local areas that make the whole herbs and things like
Yeah, that's what I'm saying. I'm trying to say that the two things work really well together.
In China now, where they grow plants that have been growing for hundreds of years, as you know, the Chinese medicine.
Yes, yes.
Okay, so in China, they're growing. There's the last 20, 30 years, extensive amounts of research as they isolate some of these compounds, like Danshan, salvinoic acid, oleic acid.
He's talking about in China isolating, there's been a lot of research done on isolating compounds out of plants and looking at those kind of isolates, those active compounds.
So the thing is that these things have been extensively studied. So you look and you say, well, are you using them as drugs? Not necessarily, because these things are completely different. They work multi-dimensional, even though our drugs are one-dimensional. So they don't work like drugs at all.
Well, it's true, but we're talking about molecules. And molecules do function like molecules. And whether they're drug molecules or other molecules, it's just that when we manipulate them, they function differently than they would if nature created them. It's true, but even if you look at a compound like metformin, it works on tons of genes. And just that the data it's a much bigger story. So it's not about, the biggest multitaskers we have are plants that combine lots of compounds together because they have a group of things that work together as a concert. It's a concerted effort. It's an orchestra. We're putting those things together. I'm just trying to say that we can infuse that orchestra with a strong theme that relates to whatever it is we're trying to achieve in the patient. Okay, polyphenols. This is a wonderful class of compounds, right? From all of our vegetables, fruits, whole grains. These are our antioxidants. Again, we had anti-inflammatories. I don't like that word. Antioxidants, I don't like that word. There's really no plant is antioxygen. Inhibition of NF-kappa beta and TNF-alpha. I would say even more so modulation of, control of, again, stabilization of the signaling system, normalizing the cell signaling pathways, inhibiting mutagenesis, and protecting the different networks, the neurological system, the cells, the immune system, and the cardiovascular network. Here's just a look at polyphenols, where they affect change. Up here we have the NRF2. This is the main enzyme that our body uses to generate glutathione. Many of our plants induce that enzyme to make glutathione, to quench the free radicals, the inhibition, the direct quenching of reactive oxygen species, downregulation of MAP kinases, which is part of a pathway that drives, again, transcription factors in the nucleus. And you can see here curcumin, resveratrol, even theophylline, the methylated xanthine from green tea, that's very stimulatory. Flavonoids, about 50% of all the polyphenols are flavonoids. And so you can see the effects, regulating pro-inflammatory genes, inhibiting inflammation, and working on those reactive oxygen species quenching networks. So here's a couple of herbs. Turmeric. Turmeric is definitely the limelight herb these days, and I think it's great, but I think if you took just about any herb from that category I described of the blood circulation and blood stagnation relieving herbs, we're going to find that they all have really amazing properties. It's just that we haven't studied them to the length that we have with turmeric. And Bharat Agarwal from MD Anderson, who had some problems recently and kind of retired, he did a lot of work on turmeric and made it sort of, again, he was a big part of pushing the limelight status of that herb. But it is an incredible herb, and when you look at the multitasking ability, not only with things that we've been talking about, NF-kappa beta, TNF, the COX pathways, but so many places all over the body, all over the cells, and just the way it influences positive change in the body, and the amount of research that has documented that change, whether in vitro and in animals and even in humans, it's really mind-blowing. It's really amazing, and I wish we had that kind of research on all of our plants. It would be phenomenal. Green tea. This is a Camellia sinensis in China. It's a revered plant that, if you're in China, the tea farm plantations are all over the place. People, very often would drink a pot of tea at each meal. Green tea has so much protective effect on the body, protects us from cancer. It's very preventive. It's got a lot of anti-inflammatory activity. It's got a group of flavonoids called the catechins, epigallocatechin gallate, EGCG. That's kind of the main compound in green tea that's been researched extensively for its role in cancer and for inflammation, for autoimmune disease. It's got a lot of great data on it. And again, I wouldn't use EGCG as an isolate. I would use it 40 to 60%. you can standardize your green tea to be high in EGCG, but you still want a little bit of that methylated xanthine, the theophylline. You want a little bit of the theanine. You want a little bit of the caffeine. All those things play together, and the other flavonoids, the other catechins there, they will all help to make the effect profound. Turmeric, just to give you a little bit more of those curcuminoids. There's curcuminoids 1 through 4. There's a little example of the molecule there. You can see, it's a member of the ginger family, grown extensively in India, but also in kind of throughout South America as well, in China. In Chinese medicine, we talked about turmeric being an herb to promote blood circulation and dispel blood stasis. It's acrid, it's bitter, and it's warm. It's one of the things that people always go, I've got inflammation, I'm going to take turmeric. Well, I mean, is your inflammation, is it kind of a hot condition or a cold condition? What's your pain like? Is it a burning kind of pain, or is it like a sharp stabbing pain? How do we use turmeric in the way that it's appropriate? Again, from a Chinese medicine, or even just from an eclectic medical perspective, you want to find out what's the right plant for the right pain. And turmeric is not the right plant for every kind of inflammation or every kind of pain. That's just, everybody's going now. It's so easy to market turmeric because everybody knows about it, and you can go get it at any store, so everybody thinks turmeric is the bomb. Well, turmeric is good, but it's not the best, and it's not the best for every condition. So just keep that in mind. Yeah, question?
What would you recommend for burning pain, like neuropathy?
Burning neuropathy. I normally use like a combination of things. With nerve pain, I love hypericum, just in general. I love hypericum oil. I love magnesium for the nerves too. I use the gel of magnesium. Often combine it with DMSO, and I'll put some, I really like aconite and gelsemium actually, both of those for topical, for burning pain. You can use it internally if you really know what you're doing, and you use small doses like drop doses, but normally I just use them topically. But for hot pain, aconite is the coldest plant in that we have. It's just, a teaspoon of the 1 to 10 extract will cause respiratory arrest because it's so cold it just stops movement. The neurological system will just go to sleep and you'll die. So the plant is amazing because it's so powerful. And I use the plant, and it's great both internally for headaches. It's great for migraines where the people have extreme vasodilation. It's really incredible for that application, but you got to know what you're doing and know what you're looking for. But it can be really helpful. So aconite. It's called Aconitum napellus. In Chinese medicine, we use Aconite carmichaeli, which is also a very powerful plant and is also the coldest plant. But when we use it in Chinese medicine, it's treated, it's cooked. And when it's cooked, the root is simmered for hours, and we keep taking off this layer of foam that occurs on the surface of the water. And over time, all the foam goes away, and that's all the toxicity, that's all the cold stuff. And then it becomes the hottest plant we have. It's called fuzi. And it's like it's from the fire school. It's so incredible that it can invigorate the kidney, the adrenals. It can just bring fire into the body. Of course, it can be way too much for a lot of people too. Turmeric powder, I was saying, 3 to 10 grams a day. I normally dose it in teaspoons. Great for cancer patients. It's something that people can get real easy. You can put it in a smoothie. People can tolerate it well. When you get into curcumin, you got to be a little bit more careful. Again, you've concentrated the curcuminoids and the curcumin out of the turmeric, and so that is an isolate. Again, like the gentleman said back there, it's a naturally formed molecule, so it has a lot more affinity for our natural systems. It still works. It works, really brilliantly, but a little bit less on the dosing. 1,500 to 4,500 milligrams a day. Some of the dose escalation studies, like at MD Anderson, did go up to 4 to 8 grams a day, combined with Celebrex, and really powerful results. But a lot of diarrhea and gastrointestinal pain when you get high dose with that stuff. Here's just kind of a look at curcumin's targets. It's just so huge. Look, COX, epidermal growth factor, TNF, HER2, that's the human epidermal growth factor receptor 2, that's the target in breast cancer, and Herceptin. You've got BCR, that's the target of another leukemia drug, VEGF, vascular growth factor, you've got tubulin, the topoisomerases, all these, and there's another slide that all of us keep showing of this circular network of all the places that turmeric just, hits pathways over and over again. So, I'm just cracking up. I was just looking at a couple of colleagues out here that just put their hands on their heads, and I'm like, God, is it turmeric? I don't know. Is it Japanese knotweed? I've hit this a bunch. The resveratrol targets NF-kappa beta, the COX and LOX, interleukins. It's a stilbene. I was saying it's a stilbene. It's a compound that the plant makes. It's a phytoalexin, protects itself from fungus. Amla I was going to mention here, which is kind of a very phenolic-rich plant, a gooseberry from Ayurveda. It's got a lot of these quenching, free radical scavenging kind of components in it that downregulate the inflammatory response. Like I said before, those reactive oxygen species, whatever they be, all kinds of different mediators in our body that trigger inflammation, those things can be sequestered and can be cooled and shut down so they don't induce the inflammatory response. Hujiang in Chinese medicine, the Chinese knotweed, it's the richest source of resveratrol we have on the planet. It's naturally occurring up to 20% of the plant can be resveratrol. It's really beautiful, and it's got, that plant addresses these three big pathological factors. Phlegm, in Chinese medicine, phlegm is a big factor. It's not like just the snot coming out of your nose. It's all kind of this very coagulated, difficult to understand material that clouds up functioning in the physiological networks. We go from dampness to phlegm. Phlegm is this concentrated body fluid material. And then blood stasis is, again, we talked about getting cellular components that are broken down out of an injured area. It does a great job of doing that. And it also clears away heat toxins. Heat toxins are a lot of times associated with infections. So this plant, again, in a formula, 300 to 500 milligrams of like a 98% resveratrol is a very moderate dose, a good dose. It gives people a lot of support in a lot of areas. And like I said, combine it with other herbs in the formula. That oftentimes I'll combine it with herbs that contain resveratrol. Some of the pain and inflammation superheroes, frankincense. This is one of my favorite herbs of all time for sure. You know, it's from the Boswellia serrata tree. It's the sap. It's the resin that concentrates and is hardened. And in Chinese medicine, you use the whole resin. You take the resin, and you can always combine it with myrrh, mo yao, ruxiang and mo yao. And ruxiang means like fragrant milk. Milk is ru, and xiang means very fragrant. So it's like the aromatic quality. You know, the boswellic acids, and you think about the essential oil of boswellia, how important it is for pain, how great it is topically, and how internally this plant modulates inflammation. It's one of those herbs in Chinese medicine that's in that category of herbs that remove blood stagnation, and it also promotes tissue regeneration. And why does it do that? Because it's so good at getting the junk out of the way so the body can heal. Feverfew. This is a plant you don't see often these days. I think part of it is because feverfew is a little hard to, you've got to harvest at the right time. It's a fragile plant, these little flowers. It's so beautiful. It's such a representation of that bright yellow summer energy. And it's a little hard to keep it fresh and active. I think some of the herb keepers here would have more information about that for me. But you can get isolated, you can get extracts that have kind of a concentration of the parthenolide, the primary compound. It's a sesquiterpene, lactone, that has a lot of activity and has been studied. It's shown to inhibit a lot of these inflammatory pathways. And feverfew, of course, we know has been great for headaches, and there's some really good human data. It does inhibit migraines. It's reduces the severity and the frequency of migraines in people. I don't find it to work in all cases, but it can be a nice adjunct. Oftentimes with butterbur, combined together, they work really well. And then doing your other specific formulas for the perfect remedy for the person's specific type of headache. Magnolia bark, in Chinese medicine, ho po. We also have xin yi hua, which is the little bud that comes up, the flower. It's really beautiful. You see how beautiful those flowers are. They come up, they're just so big and rich and so aromatic. It's that aromatic quality that creates movement. It invigorates things to happen in the body. It clears up dampness and phlegm, and it starts to help the body descend energy through the digestive tract, and it helps to resolve digestive tract inflammation. A lot of times we're concentrating what are called the hinochiols, and magnolol and hinochiol, these primary polyphenols in magnolia that are really heavily researched these days for their influence on inflammatory signaling networks. This plant is really wonderful, and if you get into the 50% hinochiol, you get some really powerful results. Again, with that plant, if you get the dosage too high and you've concentrated it that high, it can be a little hard on the tummy. So you got to just watch the dosing with it, but it's really effective, and you can use it in pretty good amounts. Something in the hundreds of milligram doses for sure. Andrographis. This is Chuan Xin Lian in Chinese medicine, the king of the bitters, a very bitter plant. And, in TCM, bitter clears fire, right? It resolves heat. The bitter flavor, the bitter nature of things, that flavor clears away heat. So always remember that. So bitter plants are cooling. Think about the big bitter plants like Coptis, right? So yellow and so bitter, so rich in berberine. The berberis plants like golden seal, our local Oregon grape, the mahonia. These are plants that have just tons of this berberine, which is so cooling and bitter. So this is another really bitter plant that cools the body down and has that yin effect on the inflammatory network. Starts to calm and cool it down. This is a plant that's been known to be very effective in a lot of infections, especially in viral infections. I really appreciate Andrographis, and a lot of we've been concentrating Andrographis into a 50% andrographolide extract, and I've noticed a lot of companies are doing this now. They're kind of starting to kind of extract a little bit more towards the andrographolides, which are more specifically inflammatory targeted rather than kind of their big sort of immune influence and antiviral activity. But they still will have a lot of that. It's just that we don't have as much data and really not the traditional data on Andrographis. With some of these plants, traditionally what you would do is you just give a lot bigger doses to get the amounts of these compounds. Nowadays, people want a capsule. You can't give a person 30 capsules, of one herb. It just doesn't. They're just not. They're like, what are you talking about? And I'm always like, no, it's cool. It's just like, imagine in the old days, I'd give you like a bucket of herbs and you'd cook them all every day. And she's like, what? I'm like, yeah, no, you just 30 pills. They're like, I'll take 2. I'll take 2 pills. They're like, okay, how do I get 2 pills in here with herbs to work? It's really hard. So, it's sort of why the movement towards concentrating some of these active compounds has been happening these days. This is a plant here, Corydalis. Yanhuso in Chinese medicine, another one that invigorates blood. It removes blood stagnation, promotes the circulation of qi in blood, alleviates pain. This is an herb that's combined with other herbs often to direct where its pain-relieving qualities are. If you wanted to go to the head, you'd use ligusticum. If you wanted to go to the right flank for kind of liver pain, you'd work with Melia tuscendon. There's a couple more I'll list for you guys in the next slide. But it has really powerful analgesic and anti-inflammatory properties. And you can take it in pretty good doses. The standard doses that are in kind of like 9 to 15 gram range, but there are bigger doses you can use, and it concentrates a compound in the plant, an alkaloid called THP, tetrahydropalmitine, which is a known agonist to the mu receptor of the opioid system. So it has an opioid-like effect, but it's not addictive. It's been studied extensively in China, and it's really good for pain. So some places you can find concentrated Corydalis where you get, more of the tetrahydropalmitine present, and you can get more of that kind of pain-relieving quality. There's also some sedation qualities, but I've done a lot of research on this plant extensively, and there's a ton in China, and it's approved in THP as an isolate is approved in China as a medication, but it's they're not letting it out of the country over 50% for kind of supplement herbal sales. But this plant is really powerful. It can be combined here, like I was going to say, with boswellia and myrrh when you have injury with pain. And again, it's not just going to, it has a little bit of a modulating effect on that opioid system for the pain relief, so calming those, hyper destabilized nerves around the damaged area. But it's also going to be invigorating the blood and resolving the blood stagnation to get the healing response going. You can combine it with cinnamon for menstrual pain, like I said, like with ligusticum for headaches, and for that right flank pain with Melia tuscendon. One of the things they do in China is like they give a more of an invigorating, pain-relieving quality by frying it in vinegar. That's something that they do with a lot of herbs in China. The preparation is a big part of what makes herbs work. Some reports use up to 30 grams a day of that plant, and that's a pretty good dose. Yeah.
So, if you have someone that's yin,
Sorry, was that?
someone that's yin,
Sure.
is something like this okay for them?
It is.
It's not as hot.
Nope, it's not a hot herb. Nope. Yep. Exactly. And most of these plants, so again, when they're really bitter, oftentimes bitter and cold go together, and there's some acridness, but it's that kind of cooling nature. Yin can be damaged by bitter. If it's just like with anything, if you cool things off too much, with yin you have to nourish. You have to use things that are actually, like I'll talk about if we get a little bit further here, the yucca and the rich saponins and the plant compounds that are they hold fluid in the body. Those are really important. That yin nourishing quality is important to combine, because if you just drain away material, you'll drain away too much of the yin. So that's a really good point. White willow bark, I think we all know this plant so well. It inhibits so many different pathways. It's got a lot of research, some randomized clinical trials in Joint pain, low back pain, and headaches. Love this plant, and it can be concentrated with, you've got 30% salicin in there in the plant. Aspirin, of course, was generated from this compound. Acetyl salicylic acid is just an acetylated form of salicin. Salicylic acid was added. They added the acetyl group so it was a little bit more easy to take when it was concentrated, but it has other effects. It also acetylates platelets. So aspirin will inhibit the aggregation of platelets. And every platelet that's been exposed to that aspirin will not acetylate until it's the end of its life. It only has a 7-day lifespan, so you've only got that much time. But so when you use the salicylates here, they don't do that. It doesn't have the acetyl group, so you can't use white willow in the same way to inhibit the clotting. That doesn't have that effect. Peony, one of my favorite plants here, great for the liver, softens the sinews and the tissues. You combine it with licorice for muscle spasms, for muscle tightness, like in a 1-to-1 ratio. Peony is a really great plant for any kind of spasticity, and a lot because the liver controls the tendons in the body, those connective aspects between the muscle and the bone, between the spleen and the kidney. That's where this plant works really well, to soften the sinews and calm things down. The peoniflorin has been shown to be antispasmolytic, neuroprotective, calms inflammation. Beautiful plant. Lots of good data too. I just give this to you guys. This is just a little sample formula that's worked really well for me for psoriasis. You can take a look at that. This is a granule-based formula. They're 5-to-1 concentrates of these herbs. Put these together, and it just works for a number of patients. Again, not always the right formula for every patient, but with psoriasis, we really have to get down to the roots of this thing. It's emotional, it's spiritual, it's the diet, it's the lifestyle choices, it's all the plants you can use to try and help them, and it takes time. But this is something that I've used successfully in a number of patients. I don't have much time left, but I'm going to try to just get through a couple more slides if you can hang in there for a couple minutes. Fish oils, right? Icosapentaenoic and docosahexaenoic acid. Both of these work on that, regulation of the arachidonic acid, those COX and LOX pathways, and the prostaglandins. They regulate the prostaglandins really well to control inflammation. Fish oil is definitely another one of those limelight substances. It's like everybody's like, well, I take fish oil in my multivitamin. It's like that's just the most common thing. It is good. I think it's a good thing. Again, too much of it's probably not necessary. Although if you have like traumatic brain injuries and neuroinflammation, there's some really good data coming out on high doses of EPA and DHA in those cases, and all around it is a really good anti-inflammatory, but it's not going to take away the pain so much. Sea buckthorn, and then GLA, gamma-linolenic acid. These are, compounds that come from plants like borage, the evening primrose oil, black currant. They're the sources of the gamma-linolenic acid. And the sea buckthorn has a great mix of carotenoids, which are very good, reactive oxygen scavengers. And it also has something called palmitoleic acid, the omega-7, which is really enriching, again, more of a kind of a yin element. Sea buckthorn oil is a nice one because we were talking about inflammation and, cooling things off and clearing away the stagnant components, but then we also need to start nourishing and rebuilding, and we start to have to bring in the yin aspect and quench the free radicals, but also have the tissues hold moisture, get them to hold the blood and change the electromagnetic potential so that the blood can really stay in the tissues and the whole immune system can do its job of rebuilding and the cells can replicate efficiently. The GLA is really cool. It's converted to prostaglandins, and it actually helps to decrease the inflammatory response. Just to say a little bit about the difference between omega-6 and omega-3, you guys pretty familiar with that? The omega-6s are really coming more from, the nuts and seeds and, a lot of the things in our diet like corn and soy, the oils and things of that nature, and sunflower. These are places that we get a lot of omega-6s, and just how we've been kind of weaving these kind of cheap food materials into a lot of our foods. The American diet is at like about a 15-to-1 ratio right now of omega-6 to omega-3, and according to most experts, it should be about a 2-to-1. So try to shift people over towards omega-3 rich diet. And the fish oils become a really big part of this because they're primary omega-3s. There's some really good omega-3 products too for vegetarians that are more algae based. There's some nice omega-3s in algae and those sea-grown plants. Here's a story about osteoarthritis, another aging-related inflammatory condition where there's this remodeling of the bones under the inflammatory influence, the degradation and the remodeling of the bones. I'm just going to go right into the plants. Devil's claw. This is the harpagoside-rich plant that has been used by the Native Americans for joint pain for a long time. I think David probably would talk at length about this plant. It's got some really cool research in it for joint pain and soreness and stiffness. It's done a nice job of relieving that in people while also helping to heal the trauma. It's not in the category of herbs to remove blood stagnation because it's not a Chinese herb, but it may be. White willow we talked about with the salicin, another one that's really great for joint pain. You can combine these in a formula. And then I've got yucca here too, which is kind of one that you don't think of. It's in the asparagus family. And if you know the asparagus plants like the tianmindong, that's the shatavari in Ayurveda, it's the wild asparagus tuber. Very nourishing to the yin of the kidneys. Very good for fluid metabolism. Very good for enriching the tissues. Keeps the vaginal tissues dry and moist. It's a really beautiful plant that way. Also the Ophiopagon, another asparagus family, Mymandong, good more for those really delicate lung tissues to moisten them up and keep them rich. And so this plant, yucca, has a lot of the same kind of quality of holding on to that moisture in the yin, and it regulates inflammation, controls that NF-kappa beta release, which is that yang expression again of breakdown and move forward, clear out energy. So sea-derived inflammatory modulators, salmon cartilage. Salmon cartilage is really cool because it's got all these different amino acids in it, all the things that make up the synovial fluid. So we want to take in, again, like back to traditional medical systems all over, if you have a problem with a system, you'd eat that system. If you had a problem with your kidneys, they'd give you a kidney out of the animal. If you had a problem with the liver, you'd eat liver. And this is not some sort of like weird voodoo magic. I mean, when you get down to the science of it, you show like the materials that the body can use from that, what you're eating can then be used to restore and rebuild that actual tissue in your body. The same is true of the cartilage. And those cartilage proteoglycans, they control inflammation in the joints. They're really important, and they're rich in the salmon cartilage. I put green lip mussels up here as a source of glycosaminoglycans. It's good to combine these things with the chondroitin, the MSM, and the glucosamine, right? Glucosamine often, comes from seafood, so vegetarians don't normally use it. There are some veggie sources now, but those are all sulfur-rich compounds that help bring the sulfur component into the synovial fluids, and those glycosaminoglycans are part of the structure of that fluid that lubricates the joints. These are some assistants to help when you're taking these plants. Any of them that we mentioned, they're all enhanced by these kind of plants. Ginger, rich in the phenolics, and I told you about those gingerols and things, the zerumberone, things that actually do downregulate inflammation, but that's really secondary. I want the ginger there to help your body absorb the materials. I want to enhance your digestion. Long pepper and black pepper, sources of bioperine. This has gotten a lot of attention lately too. It helps to increase the body's ability to absorb plant materials, absorb compounds. That's also really important. And you can see there's some good data to enhance the absorption of curcumin by 2,000% in a human study. Epigallocatechin gallate did the same. It was something like 1,200%. Or there's resveratrol, 1,500%. So huge increases in animal models and in humans using black pepper. It's just a small amount. And bromelain also, as a fibrinolytic enzyme, it digests proteins. It's great for getting rid of the fluid around the edema, like in a joint injury or something like that. But it's also really helpful for digesting the materials as they come into the body. So when you take bromelain, you normally would take it with nothing else, right? You take a little water with it. So you don't want to have proteins in your body. You want it to get into the duodenum and get into the bloodstream so they can start digesting the fibrin there. But if you eat a bunch of food beforehand, it'll digest the food. It'll digest the proteins there. And so when you take the bromelain along with some of these compounds, you're helping to bring those compounds in, helping to network them a little deeper with enzymatic activity. So I wanted to just mention the cortisol system. This is our primary glucocorticoid. I talked before about if you have too much cortisol over a long period of time, it's very bad. But if you don't have enough cortisol, it's also very bad because cortisol is our steroid. And what do we use steroids for? You go to the doctor and they give you steroids. Why? Because it shuts down the inflammatory response. Because it stops the immune system from going crazy. It'll slow everything down and shut it down. So we use cortisol every day. And so when you are under stress and your body's creating inflammation and your interleukins are going crazy and your immune system's starting to get fired up, you need to calm that down and quench it, and cortisol is the way to do it. But if you ask the body to do that every day for a long period of time, eventually the body's like, I can't give anymore. I've been giving you all I have. Chinese medicine says they look at something called essence, so you only have so much of it. You can hold on to it through your life through good choices, but you only have so much of it to distribute. It's part of that insulation I talked about. It's part of that yin nature of quenching the fires, putting out the fires. That's where it comes from. And when you use it up every day, there's just not any more left. Your reserve tank gets too low, and then you get into adrenal fatigue, adrenal exhaustion, exhaustion, collapse, and maladaptive stress syndrome, and your body falls apart and you have disease. Don't let your patients get there. Don't let yourself get there. Stay strong. Regulate your stress response. There's a guy, Dr. Jeffries, did a lot of work on cortisol. He actually would give people cortisone at 5 milligrams, hydrocortisone, 4 times a day. 3 or 4 times a day, depending, 15 to 20 milligrams of cortisone a day. And he had incredible results with people with autoimmune disease. He would use it to control their immune system, and it worked for them. I think I don't know how you'd get off of it once you were on it for 25 years, but that was his approach. And it just kind of like gives you the idea, again, a lot of our plants, a lot of these yin-nourishing plants are very steroidal in their nature, steroidogenic. They have that steroidal activity to calm and quench that response. You can use whole adrenal or adrenal cortex. I use it a lot for the kind of adrenal rescue. I've talked about this in other talks. Gave you some kind of dosing ranges. And let's put the plants and the whole plan together and we can get people well. Thank you all so much.